Okay, I think I can make already an announcement. So I will bring chat, but I would suggest that unless it's an urgent question, I will try to collect the questions and answer them after the presentation. But I have a window kind of up here. But if there is something urgent, I would just incentivize people to unmute and speak up. So kind of I don't see a big hurt to stop the presentation and explain certain points. Okay. Okay, let me just keep. Yeah.
All right, let's get going and start the seminar. Welcome back, everyone. And also we would like to welcome back Svetlana Ikonnikova to the Bureau for this talk. Svetlana is an associate professor now for resource economics at the Technical University of Munich, where she also serves as a research director for the University Center for Energy Markets, in addition to be a senior energy economist here at UT. With over 20 years of professional experience, she holds expertise in energy economics with a special focus on the energy transition and security of supply, international energy trade, and clean technologies. Svetlana holds a PhD in economics and management from Humboldt University in Berlin, MS degree in applied physics and mathematics from Moscow Institute of Physics and Technology. She has published her research in top peer-reviewed economic and interdisciplinary journals and has delivered numerous presentations at industry, government, and academic conferences. With the diversity of her background and expertise and experiences, Svetlana specializes on the modeling of complex economic systems, integrating different perspectives in order to understand markets, evolution, and dynamics. And today, she will talk about hydrogen versus biofuels. Svetlana, take it away.
Thank you. Thank you very much for your nice introduction. So today I would like to present some ongoing research about the different pathways that the decarbonization of the refineries may take. So refineries is a part of the chemical sector, and from that perspective, the discussion that I would like to set up may have the application to other sectors, including ammonia production and so on. And so looking to that, I would like to start with some practical understanding on what's going on, why it's going on, and then draw some more general economic intuition that would be helpful to understand how complex the transition is and how not black and white the discussion about the choice of the different fuels or technologies is. And so let me start with a small piece of the data that I would bring you here. Is first, let's look into what are we talking about when we talk about refineries. So refineries quite often characterized by how much of the refined products they produce. So the key products, as you may know, is their gasoline and diesel. There is their conglomerate of other products, but those fuels that we use in the different means of transportation is a main outcome. And with that, the trends in terms of the growth in transportation throughout the world translate into their growth in the global production of different refined oil products. With that being said, however, what we see is that that growth is not evenly distributed around the world. So we've been back and forth with a little bit accelerated development in the production and then slowing down. So now we're down to below 2% of the annual growth, so about 1.8 if you look into the data for 2003. And what we see there is that some countries would experience the decline in the production, whereas others will show quite rapid expansion. And so I bring you here the top three with a striking number. So on the negative side is Germany, and we'll talk more about why do we see these trends in Germany and the European Union in general. A bit surprising is Saudi Arabia with some decline in production that it provides not only for itself, but also delivers to Europe. And in that regard, we'll look into both what happens in Saudi Arabia as well as the UAE as part of the trend characterizing Europe in general. On the other side of the globe, what we see is a fast-growing Asia-Pacific region, with China keep rapidly increasing its production, India, Kuwait, and we'll talk about the US in a bit. And so with that, these two centers, so two gravity centers in terms of the production on the map that you see, show the trend that we associate with the decarbonization. So as European Union is on the path to reduce its greenhouse gas emissions, not only CO2 emissions, but emissions across the board reduction, it implements a number of different policies and regulations that put pressure on both the use of transportation and the use of oil-derived products, such as gasoline and diesel, being substituted by other fuels, about which we will talk about. On the other hand, we see the developing world that fast growing with its ability to afford transportation, afford personal vehicles, increase in trade with that, increase in the marine transportation, in the aviation, less concern, or at least putting less pressure with regard to the decarbonization efforts. If we look in a bit more detail into their top producers and top consumers, so the most recent trend shows that US now takes their top position in both as a producer as well as a consumer. Not surprisingly, China takes the second position, but with that, it takes the second position in both, again, as a producer and as a consumer. So you can see that the European countries, including Germany, are more close to the bottom of that list. But it's better to look into those trends in a dynamics. So back to what we just discussed on the annual basis, let's take a leap and look at how numbers changed over the last 2 decades. So I here provide just the milestones for their major players that we'll discuss today, the US, China, and Germany. And so look into them, what you see, the US grew up from 860 to 920 million tons produced products from 2003 to 2023. And that production was supported, as you may guess, by the increased production of the oil in the US thanks to the shale oil. On the other hand, despite their overall increase in production that's supported by the development of their domestic resources, United States also shows trends similar to Europe, although not as striking, not as dramatic, with regard to the reduction on its consumption. So in other words, if you compare the numbers that in the past, US was satisfying its own needs with a 860 in both consumption and production. And now it produces more that it consumes, selling the rest to the world, supplying it to Asian regions and others. On the reverse trend, China has been growing in both the production and the consumption, and manifold so. Germany, as a representative of the European trends, was in the past also carrying the capacity that would allow it to convert the oil that it would buy from different countries into their produced oil-derived fuels that it would use to satisfy its own demand. And that's why the production was roughly equal to the consumption in Germany in the past. Now we see that the decreasing trend, Germany still utilizes its capacity, although now they less serve to satisfy its own demand and more to satisfy demand of other European countries who do not have as much as capacity. And so with that, even though the pressure is put both on the consumption and production, the production in Germany does not fall as dramatically as a consumption. And so the overall, looking to those numbers, now that we realize that there are trends that show that we see decrease in the consumption in the developed countries and the increase in consumption in developing countries. So if you look into the US, that doesn't have as many dramatic policies as EU. We see that when it comes to their transportation, which is a primary sector using derived oil products, the US is not very far from Europe in terms of the using biofuels. With that, those biofuels in the US are primarily produced domestically, whereas if we look into Europe, then Europe splits and has both the biofuels, which is a primarily substitute and complement to its consumption of the transportation fuels. It uses the biofuels produced domestically and increasingly so imported from Asia, China specifically. And so altogether, those complex trends in terms of the pressure on the consumption with their trend to complement with the new regulations requiring so, oil-derived products with the bioproducts, which have reduced emissions, we see that major economies, including China, they start increasingly use the biomass-derived products. And altogether, that justifies the question that requires some research, not only on the European side or not only on the US side, but more on the global perspective, on how that competition will play out between those different fuel types and through the fuel between the different production technologies, including primarily first the traditional versus biofuels, but next, as we'll talk, also synthetic fuels. So the competition is the main focus, but the competition, this is when you already compete with supplies. The question before that is, what capacity do you install and how do you make those choices? So now to speak a bit more on the capacities and land on the proper research questions, let me show you another piece of analysis that we did looking into the sustainable aviation fuels. I on purpose bring the example for sustainable aviation because we hear a lot about on-road transportation. So what's going on with your cars, what's going on with effects on their maritime, on their shipping. But sustainable aviation is yet another area that increasingly gains attention. So which fuels do their air jets using? And here what you see the two plots that show the calculations done for Spain and Germany, looking into the solid curves, the solid blue line for Spain and solid red line for Germany, on how the current production capacity been built to provide the sustainable aviation fuels. Sustainable aviation fuels, as I'll say next, may use different technologies, but the key point across all of those technologies is that they do not use the oil products like the traditional refineries. And so what you see here is a plot that shows on one side how we at the moment been developing production capacities, setting up the investment plans. On the other hand, with the conus-like graphs on the light blue on the left graph for Spain and on the light red on the right plot for Germany, on how the demand is expected to develop. You see that by 2050, there is a big uncertainty with regard to how much we may need. The uncertainty comes from the fact that the regulation has been set, but still remains flexible with regard to how much and what kind of fuels and which air carriers may substitute on one side. On the other side, that uncertainty is fed by the question on how much the aviation will be substituted by the other means of transportation. You may have heard that in countries such as Spain and France, it's already been established that for the short distance travels, you cannot take airplane, you have to travel by train. And so this is one of the examples on where the uncertainty comes from. The question is, if we decide to change the distance, which can be traveled by jets versus the trains, so we can further decrease the demand for sustainable aviation fuels in the future. But disregard this uncertainty. What that plot shows is a very clear understanding that we are far behind on planning the capacity for what we would need if we look beyond the next 10 years. So the next 10 years, we seem to be fine, but after 2035, it's a big question on where we get those volumes and what type of fuels we'll be using. And so with that linking their complexity on transitioning and the use of the fuels on one side and investments in capacity on the other side, let me land on the two major research questions that currently get increasing attention. One is a changing geography on their supply of different fuels and the market competition. And another major question that comes as a complement to that one is what kind of capacity using which technologies should be built when it comes to the conversation about the fuels used in the different means of transportation. And here the fuels that become the key types of fuels considered include the biofuels, synthetic fuels, and maybe there will be something else, but for the moment there are these two major classes. I will give the details on these two classes in a bit. So in what follows, I will focus on that research questions driven by the following inspiration and motivation. So coming from Europe, but also looking how other countries implement similar regulations, let me bring your attention to, first of all, the recent EU directive on the automotive fuel. US has a quite similar one. So that one mandates the minimum of the renewable energy used for the fuel production or the reduction in the greenhouse gas intensity of the fuels put into the transport on the roads. The second one covers the aviation, so another type of transportation, again, setting up their different targets for throughout their into the future by 2050, setting a target of almost 70%, reaching out the decrease in the emissions. And so that the regulation that was fed into the plot that we discussed earlier. The third major one is a maritime regulation that also, once again, aims for the reduction in the greenhouse gas emissions. And these regulations, as you see, not only set up the targets, but they also have the details with regard to which fuels would be favored in a particular regulation, in a particular type of transport. But all across the board, it says that even if you consider the substitution from aviation to the railroads by or between the railroads and the cars. So there is no get away with that. So there is no proper carbon leakage because you have to reduce the emissions all across the board, which means that the transition to those different fuels have to happen. And so with all that, what we see is that the consumers get in touch with the producers of different fuels, trying to align with them on the choices they make with regard to types of transportation they use, whether it's ammonia ship versus the natural gas versus hydrogen ship versus heavy oil, whether this is the car sharing that will use more hydrogen versus synthetic fuels or else. And with that, we see that the consumers, along with the producers, are pressured to reduce the emissions. That develops their quality of the fuels, which we associate with emissions. And we already see, as it follows from the snapshot here that was published on the Alternative Fuels Observatory. So what it shows that you can see quite a bit of a price differential when it comes to the costs per 100 kilometers, depending on what kind of transportation you use. So that specific table is just for different types of cars. You can think further about the similar thing for other fuels. And so that inspires us to go to the modeling that would help us understand what capacities might be established, what are the complexities on making the investment decisions, by first turning to the following. So we now say that there is now not just the competition between the fuels in terms of prices as it was until recently. Now we see that the fuel competition goes on in two dimensions. One of that dimension is price, and another of this dimension is emissions. With that, we'll look into the so-called utility. So in other words, what you as a consumer would feel as you pay the price for your fuel for the quantity of the fuel you consume. So that's one part of your utility. And this is what we were focusing before when we'll talk about how the consumers make their choices. Now we have to take into account the emissions that would be associated with a quantity of fuel that you will consume, whatever the portfolio of fuels you have at hand. And those emissions are weighted, associated with what you, as a fleet, is pretty clean, you use it's hydrogen-based, or you're already on the synthetic fuels, your sensitivity might be quite low. Or on the other hand, you can also take a situation when you consider a country where the consumers are not pushed by the regulations to pay attention to emissions. And then again, they can consume the quantities of the fuel with a really low elasticity, with a low sensitivity. With a sensitivity normalized to 1, we, on the other hand, can look into those consumers who really have the urge to switch to clean fuels because, for example, otherwise they have to pay heavy fines. And so normalizing the whole consumer base that might be exposed to regulations or might be emission aware, we develop so-called elasticity or sensitivity curve that shows how the number of different consumers would be sensitive to buy the fuels with the low emissions. Okay. So with that, we move next to the next modeling step where in economics, we consider now their competition, which is a price quality competition. That competition helps us to identify what kind of premiums the producers of their fuels with a better quality, in our case, low emissions, may charge. These premiums are derived coming from the condition that's called indifference conditions. In other words, you will try to charge your consumers who are sensitive to the emissions as high price so that they are just barely staying with you, but on the brink of switching to a dirtier fuel and paying the fine. And so this is what you see captured here by these two equations. So in one case, you see that the indifferent consumer would compare. There is a price, for example, that I would have to pay for hydrogen or synthetic fuel based on the hydrogen. And feel sensitivity or pressure to reduce my emissions that will be associated with that quantity of hydrogen times my sensitivity. And I compare that with what I would pay, for example, for their biofuels, minus my sensitivity to the emissions associated with biofuels. And if these two things are equal, I'm indifferent to go and buy my biofuels or the biofuels-based car, or go and buy hydrogen or synthetic fuel-based car. This is kind of the two indifference conditions that lead us to the definition of, first of all, on how the distribution of consumers, so kind of here is now let me go one step back. So if this is a sensitivity that shows how much quantity I may buy given my sensitivity, then I can convert this into their other relationship, which shows me what % of consumers would buy one fuel versus the other, given their sensitivity. So now I defined through these two indifference conditions the condition that says that the portion S of consumers would go, in this case, to buy diesel versus the biofuels, which will be determined by the price difference and the difference in the emissions of the two fuels. So this is a setup that leads us to the definition of the demand, because quite often there is a question, where do you get the demand? So in this case, we derive the demand by knowing what the usual quantity or the kilometers that we see driven, flown, or traveled by sea. And then we see how those kilometers will now be allocated to different types of fuels in association with how the regulations impose the restrictions on what the emissions could be. So this is a mechanics. I will kind of not show kind of further details, but kind of through this mechanics, we're able to derive the demands that looks like this, that shows us now how the demand for a particular fuel may decrease, not only with an increase in price, but also with the increase in emissions. And this is the kind of key takeaway that we'll go and kind of use in the modeling approach now, taking the refinery investor perspective, where we'll look into their how the refinery producers will make their decisions on which type of refinery to expand or how to retire their existing capacity. So there we take the two-stage approach. First, we say, let us consider what goes into the production of the refined products and what the associated costs are. And then we assume that they're all profit maximizers. In other words, you would like to get as much premium as possible, considering that there are competing fuels that you have. And so now a quick word on how we look into those technologies. So we collect the data on different capacities that have been installed in the US and Europe. We look into their descriptions of the different processes. Here you see some schematic, looking into how the traditional refineries would primarily use oil and then natural gas for heating and small portions of electricity, meaning that even if you use a clean electricity, it's not going to help you a lot. Then if we look into the capacities that's currently being built and exist in Europe and the US for the biorefineries, then we find that the primary input or feedstock there is a biomass. And then it also complemented by the natural gas that's used for heating and some electricity. The biomass derived by fuels now can have more substitution between the natural gas and electricity. So in some cases, for example, the heat would be electricity based or might be based on the different coal, the combined cycle plants. But altogether, the main savings in emissions comes just from the substitution of the oil to the biomass. The last option that's considered to be the least emission intensive is the synthetic fuels. So the synthetic fuels are produced using the hydrogen that would be expected to be either green or blue, in other words, with their minimum CO2 emissions. And then it would be combined with the CO2 or the carbon derived from waste, for example. And with the electricity, which comes from the renewable sources and will be used for heating, as well as the other energy required in the processes, would lead to the least CO2 footprint synthetic fuels. And this is one of the reasons why the synthetic fuels have been favored on one side, on the one hand, by the regulations. On the other hand, because it includes all those components such as hydrogen and electricity that we see being quite expensive or require a lot of subsidies, the compromise has been made. And so the biomass-based fuels can also be seen as substitute to synthetic fuels as long as there is least amount of natural gas used and more clean electricity is used, which allows to reduce the CO2 emission footprint of the biofuels dramatically. I will not go in details in all the different technologies, but let me just mention here that there are many technologies already out there being tested with a pilot project, but there are still more being under the development. And I would encourage you, if this is a topic of interest, to further go and check not only the conventional discussions about the footprints of their existing biofuels, for example, or synthetic fuels, but pay attention to the more recent generation that has been shown to have quite a big advantage in terms of both CO2 as well as slowly getting more energy efficient, although still quite energy intensive. Now I've been talking a lot about Europe, and you may anticipate that in Europe we do a lot on this domain, but here's a perspective from the US. So the US has also been increasing its production of those different non-oil derived fuels. Here you can see their outlook developed by the EIA that shows their anticipations. Here's kind of the year for the history that shows and confirms the trend in the increase in the renewable diesel. So this is what we call the synthetic fuel. So this is derived one step back. So this is derived based on hydrogen, CO2, and electricity. So it's derived synthetically. It's called renewable because it uses renewable electricity and renewable or blue hydrogen. By blue hydrogen, I mean hydrogen that could be produced from natural gas and complemented by the carbon sequestration. Versus the biodiesel that seems to be first losing the favor, but yet still expected to pick up potentially in the future. Looking on one side, kind of on these projections, on the other side into more updated data with regard to the consumption, we also see that the total distillate consumption, as I showed, has been stagnated and slowly going down, but distillate product supply have been more radically going down. Now, where is the connection between the US and Europe and the other countries, as I said at the very beginning, connection is the import-export, and through import-export, we establish the common grounds for the global market development and the global competition and the global price premiums. In other words, what we do see already looking into the production and the pricing data is that they're establishing the regulations on the emissions for the fuels in Europe and having the CO2 price in Europe for if you exceed the targets values has already been recognized to have the echoing effect on the prices of fuels in all across the world. So we do see the effect on the US prices. We do see dramatic effect on the China and India. The only couple of countries out of the major economies where we do not see the CO2 price effects from Europe yet is South America. So it looks like the Brazil, Argentina, those countries have not feel it yet, but all others, including Mexico, Canada, definitely feel it. Okay. So now back to the modeling. So we model the production by looking into their production quantity as a function of the inputs, and then the revenues derived from those outputs as a function of the costs of the inputs. This is just snapshots kind of to show you how their database that we've been collecting looks like. So we looked into those different types of refineries. We'll then specify the different technology. Here again, I use the example for SAF. We do it for the biorefineries as well. We'll look into the capacity. We'll look into their expected volumes. So all kind of those functions are estimated based on this data and lead us to the following rough estimations on the cost for the synthetic fuels, which are hydrogen-based, and that's why I use the hydrogen as a subscript. As a price of hydrogen, quantity or efficiency of using hydrogen for the production. And here comes the trick for synthetic fuels. We may have the CO2 which needed for synthetic fuel production because you still need the carbon in your fuels. That may come with plus or minus sign. For the biofuels, we see a similar equation, but now it's driven by the price of the biomass, the efficiency of using this biomass, and now the costs of the energies, which are primarily come from the natural gas and electricity. Looking to the traditional refineries, we see that its costs are primarily determined by the prices of oil and the natural gas used for the heating. So here I provide you the plots developed for the Europe. We hope to develop and finalize a similar analysis for the US. So what you see here is that the picture with regard to the cost of your fuel versus the energy cost, and here by energy cost I look into the aggregate cost, that picture is not unambiguous. In other words, depending on what's going on with your prices for the natural gas and electricity, you may either favor your classical diesel, your traditional oil-based diesel, or if you see an increase in prices of natural gas and electricity, which here in Europe is a especially sensitive topic, then you'll see how the biodiesel will pick up and become a more favorable fuel. So just kind of to show you where we currently are. So we are now close to 50, but in the times when the Russian-Ukraine war started, we were all the way kind of into the 300 domain. And so that shows that kind of historically, we now might be in the area where the biodiesel, oh, sorry, kind of, I have the kind of wrong notations. Sorry. There should be a switch in colors, my apologies. So we might be kind of now in the area where we see that sorry, I lost it a little bit. So kind of we might be now kind of in the area where we value one fuel better than the other. However, depending on how the energy costs develop, and with the energy cost, we especially focus on the cost of the natural gas and electricity, we see the possible switch in the preferences. And so with that, putting all the lines together, including the diesel, biodiesel, as well as synthetic or e-diesel. So kind of this is their traditional notation here. Under the different hydrogen prices, here I picked the $3 per kilogram as a target for the reduction in terms of costs set up by the European Union, up to 10 kilograms, which is roughly what we see right now. So what we see is the situation in terms of the choices get even more complex. So we cannot say that one fuel is definitely better than the other. We cannot even say the same thing about the two fuels, because as the costs in terms of the natural gas and electricity change, and as we expect a change in the price of hydrogen, we may expect that our preference for one versus the other versus yet another fuel may change. And so altogether, that leads us kind of to get back to our analytical model and establish that not only the cost of energy becomes a critical factor on when looking into which capacity, if you look into their economics of those capacities, over the next 15 years or maybe even 10 years, depending on what your preferences with regard to the financing. So the prices for key energies is the one driving factor for the choice of which refinery capacity may look the best at the moment. But the other one, coming back to understanding what drives the demand, is the emission intensity and the regulations set to limit those emission intensity. And in other words, how much you would have to pay for your emission intensity. So with that, in intuitive terms, what we come up to understanding that's also supported by our analytical derivations is that the conversation about if you would have to invest today in the refinery capacity that you would expect to be functioning for the next 20 years, you have to pay attention not only to the current key input prices, key feedstocks such as hydrogen, biomass, or oil, but you have to take into account the costs of these complementary or supplementary energy needed, especially heat, which will either come from natural gas or electricity. And the other thing is you have to pay attention on where do you plan to sell the product that you would develop, and how in that region where you plan to sell your product, the regulations put the pressure on the consumers and make them sensitive for the emissions. So in the regions such as Europe, we see a high sensitivity for the emissions, and that allows to tolerate a higher prices for the biomass, and with that, the higher prices for the biofuels. The same would apply to hydrogen. It also means that as we go with a tightening of the regulations, we should also see the upward trends in terms of their being able to, willing to pay for the higher prices. On the other hand, your premium that you may get for supplying that cleaner fuel would be constrained by what is the alternative on the market. And there is this competition between the efficiency as well as the costs with your close competitor, which is hydrogen to biomass, biomass to the traditional oil, that makes, again, the choice be complex and the region specific. So back to Europe when we put together our equations. So first, for the benchmark case, we present a case where we see that the biomass-based fuels, whether the current biofuels or the biofuels with reduced energy emissions, which may require some CCS complements, are most likely to be their preferred option unless we see a radical change with regards to their emission intensities. In other words, the more pressure on the emission is applied, the more consumers would go for synthetic fuels, because now alternatively they would have to pay higher fines. The more consumers would go for the synthetic fuel producers, the more they would be willing to pay the premium, and the higher would be the profit of the synthetic fuel producers, first because of the premium, and second because of the increased number of consumers. So this is our benchmark case that we calculate for the current regulations in place. However, back to the picture that we saw regarding the costs before, we see that depending on the hydrogen prices, there could be a wide corridor on where things may go. So if we see a high hydrogen price change, then in other words, that the hydrogen prices will not fall to $3 per kilogram from the current 10 or even 12 that we see, as European Union expects within the next 10 years, then the biofuels may be preferred for longer, even as their intensities being regulated like past 2035. Okay. The last case that we consider is a situation and the sensitivity to the CO2 price. Because what happens is besides the hydrogen price that indeed may drop, may not, the big uncertainty is currently imposed on the future of the synthetic fuels is with regard to the CO2 price. On one hand, if you have a high CO2 price, you may anticipate that there will be consumers willing to sell you that CO2 to be used in the synthetic fuel production. In other words, be a substitute for the CCS. However, if the decrease in the CO2 production will continue as we currently see in Europe, you may run into trouble of not having enough CO2 for your synthetic fuels, and that may drive the costs up. And so from that perspective, once again, we may see a different scenario developments. If the CO2 price goes high and you do have the CO2, so its costs are low, you may prefer the synthetic fuels, while otherwise you may consider that this is a less useful technology. And before leaving you with those conclusions, one other aspect that I would like to highlight is concerning the further sensitivity to the CO2 prices, which depends on the level on the either biofuels or synthetic fuels. In other words, you have to look not into the absolute value of the CO2 price, but on the value of that CO2 price as a percent of the cost for your either biofuels or synthetic fuels. And with that, we see the difference again in the sensitivity that may come from that fact. So with that, I would like to finish with understanding that looking into the profits that one may derive by installing one type of refinery versus the other, what we learn from both numerical simulations as well as analytical modeling is that the decision will depend on the expectations that the producer or investor into the refinery will put on the costs of the CO2, on the costs of the key inputs that it will plan to use, but relative to the prices of the inputs of the alternatives. In other words, if you would like to invest and consider investment into the synthetic fuels, not only the price of CO2 will important to you and the hydrogen, but also how those numbers will play out against the expectations on the costs of the biomass-based fuels. Because the competition, as I said, on one hand will be driven by the premiums for reduction in emissions, but will be constrained and further pressured down by the existing alternatives. And so that, to summarize, I would like to finish you with last thoughts that facing environmental regulations, consumers all across the world, but at different rate, will see the need to develop portfolio fuels. So we do not see that the consumers all around the world, or even in particular countries, may stay solely relying just on the oil-derived product. So the other fuels will enter into the global economy and will do so all across different geographies. But the financial incentives as well as emission sensitivities value dramatically already and will continue to do so at least within the next 20 years up until we'll reach 2050, when most of their countries will start converging with regard to their emissions incentives. And that brings their final takeaway is that the decisions on the choice of one fuel versus the other will, as well as the demand for one type of the input versus the other, whether we talk about the hydrogen or the biomass, will be region-specific, region energy cost specific, natural gas especially, CO2 price specific, and the regulation specific. And so with that, let me also reiterate that with the regional specifics, we'll see, in addition to that, that the big question lays on whether we will develop a similar liquid market for selling all these fuels on the international market or not. So our current model looks into the just the trade within the European Union, but with the observation that the CO2 prices already sent the effect to all other markets, we see that the further big expansion needed for that research, once we also have the US number, is to see the interlinkages across the regions and how the global market establishment for both biofuels as well as the synthetic fuels may have the overall pressure on the oil consumption. And with that, I would like to leave you with understanding that even though we started with a question on what might be preferred option, the answer is it depends on where you are and depends on what your expectations are. I believe that the most important takeaways from all of our both numerical as well as the theoretical exercise here was the fact that we will see both the synthetic fuels as well as the biofuels keep continuing developing and keep continuing growing, just at a different pace, as they will slowly be substituting oil products, which are still growing at the moment, but we believe are plateauing and soon should be going into slow decline. And with that, thank you very much, and I will be welcoming any questions.
Thank you, Svetlana. It's a really nice talk. And we have plenty of time. Some questions, either type in the chat box or just turn on your microphone and ask your questions, please.
Okay. I'll stop sharing so that we can see each other, and then as needed, I can navigate through slides. Okay. Okay.
Hi, Svetlana. This is Bridget. I was wondering, are you also considering water aspects in irrigation of the biofuels, or, the other environmental concerns with the biofuel production and how that might constrain?
That's a very good question. So at the moment, we do not consider it. The only way that we bring this into the discussion is through the different factors that may affect the future prices of the biomass. So in other words, at Europe, there is a currently recognized the decrease in the availability of water. And where it manifests is in the projections for the biomass prices in the future. So the biomass is expected not only potentially become more scarce, as kind of we have some regions moving into more frequent droughts, but it also expected to become more expensive because of the water costs. Otherwise, we do not consider a direct effect, no.
Thanks. Very nice presentation.
Thank you.
Any
Hello.
other questions? Yes.
Can you hear me?
Yes.
Yes.
Hey,
Ning? Yep.
Hi, Ning.
hi. Great presentation. Two questions. So you talked quite a bit about CO2 prices and hydrogen. I'm curious that if you have looked into the assumption of oil price. I mean, after all, it's substituting ultimately from oil-based markets. So is there a kind of a underlying assumption of oil price going forward?
So the scenarios that we ran, we just kept the oil at the $75 per barrel. So kind of we take the very blind assumption on oil, but we did look in detail in natural gas. And so from that perspective, you may anticipate that there will be a similar effect. So we saw that the natural gas may have quite dramatic effect on that competition. But back to linkage to the CO2 prices, so we didn't find a direct link between the CO2 prices and either the use or the prices of either oil or natural gas. So the CO2 prices are primarily driven by the pace of the transition, so how well the current industries comply with the new regulations and the pace of those regulations with regard to tightness. So I'm not sure that that's exactly was your question.
Sure, that's helpful. Kind of understand what's oil price always get. Okay, that's interesting. So what I'm just curious, how high
Yes.
did your CO2 price go, or like what kind of a range?
Currently.
Well, are you only doing current, or are you looking to?
No. So kind of we started with the current prices of a little bit below 70. So I think we're now at 69 or something. And then we take a different projections with regard to how CO2 price may develop. But by just to give you kind of a order of magnitude, so by 2050, we run the scenarios when that price may go to as low as 100. So this is for us kind of the year, this kind of low case scenario, up to 200.
Okay.
With the benchmark case being 150 by 2050, and we just kind of took the annual rate of increase. So we didn't kind of run any sophisticated fluctuations in CO2 prices. We just went to a straight line from today till 2050, arriving at 2050 at either 200, 150, or 100.
Okay, that's helpful. I was just kind of curious what type of CO2 price would eventually, encourage some of the developments. And obviously, it's one factor, but I was just, so did it get a little bit better? Like, because I know Europe have some targets for biofuel, but it has been going slow. So.
Yeah, not the part of this work, but the part of some other work that we do. So what we were able to find is that at the moment it looks like the question has indigeneity in it. In other words, your CO2 prices indicate on whether it was enough or not enough to push the industry, and so the regulations with the new intensities. And the intensity is kind of putting the pressure on the companies to go run and kind of buy more CO2. They're interlinked.
Okay.
In other words, kind of, yeah, you can drive it either through intensities or CO2. If you think the CO2 price doesn't drive it enough, you change the intensities constraints or targets, and then it pushes the CO2. Does that make sense?
Yeah.
Yeah.
Thank you, Ning. Any other questions?
Yes, I have another question, and thank you for the presentation. And I was wondering, do you plan to look into price elasticity for CO2 and for hydrogen price and compare them in order to understand on what price regulator should be kind of more focused, either providing some subsidies or making the regulations stricter?
Yeah, so that would be, let me kind of bring it up here again. So the conclusion that we end up with, where you have to look into all those numbers, is not in their absolute terms as we usually do, for example, with the NPV analysis or the expected future profit analysis. But the realization that we have to look into those in the relative terms. So at the moment we didn't do it, but that's exactly what we need to do. In other words, we'll have to, in order to see whether you would be prone to go for one type of capacity or for the other, or see whether the market for biofuels versus synthetic fuels may develop faster, we would need exactly to look into not the prices, but the price ratios and the differences in the reactions the prices would have to the change in the inputs. Yeah, in other words, kind of what matters is not your oil price, but the oil price versus the current cost to produce hydrogen or the current price for the biomass. No, we haven't looked at it. So this was the final conclusion at which we arrived.
Yeah.
Thanks
okay, thank you.
For the curveball.
All right, any other questions?
Yeah.
Once, twice? All right, if you don't have any questions, please join me in thanking Svetlana for this. Yes, please.
Yeah, I just kind of would like to end the kind of one point, knowing that who is in the audience, is that one thing that we didn't consider is we didn't consider the costs of the CO2 sequestration and the link to it, to either CO2 costs for the synthetic fuel production or not. This is actually the new theme. And that question pop up in our research, but and I believe that would be another big venue of research on how the CO2 sequestration that we ongoing now may affect or contribute to the development of the synthetic fuels. Yeah, so can we not just kind of store this carbon, but use it to develop synthetic fuels and derive yet further value to it besides kind of being fined for producing it? So I just kind of want to leave it as a future research comment.
Yeah, I think Porsche already tests synthetic fuels in summer in Africa.
Yes.
Summer they make it. So I wonder how much the impact of that would be if that's scaled up globally.
Yeah, Porsche is exactly kind of the company that I have in mind. Yes, thank you.
Yeah. Perfect. Again, please join me in thanking Svetlana for this wonderful presentation. And let's hope for the next one will be in person. We'll work out in person.
Yes,
for a visit.
Best. Yes,
and thank you again, Svetlana, and thanks all for coming. And we'll see you next week at the next seminars. Thank you.
Thank you.
Thank you, Svetlana. Really nice.